In today's video, I would like to introduce a very nice problem of Bulgarian Mathematical Olympiad edition 1975. Here is the following information. So our goal, we are going to prove this setup to 247 minus 1 is divisible by 343. In the other word, 343 divides this term, okay? So the nice thing here in this problem, we know the exponent of this one, which is easy for us to make the connection between the exponent and this divisor, okay? There is very important and useful formula which can help us to solve this problem, okay? Which is called Euler Theorem, okay? Euler Theorem can reduce this exponent to the smallest value possible, okay? Here is the following theorem. This is the general definition of this theorem, okay? So now we are going to apply this theorem on our problem. Let's check with this number. 343 is the same as a 7 cubed, okay? First of all, I'm going to reduce this one to mod 7, okay? So we have 2 cubed is a congruent to 1 7, okay? 2 to the 3, which is 8, is a congruent to 1 mod 7, okay? Now I'm going to raise number 24 as an exponent on both sides. So since we have the number 1 here, so I will have 2 to the 3 to the 24, which equals 3 to the 24, which is 2 to 72, which is congruent to 1 mod 7, okay? Then I'm going to raise number 2 as a power on both sides again. So we'll have 2 to 72 to the 2, which equals 2 to 144, which is congruent to 1 mod 7, okay? Since we have number 1 here, so the exponent here, so we'll have 1 to 144, so the exponent to 1 to 144 is the same as 1, because number 1, since we have number 1 here, so the exponent will be reduced to the number 1. So we'll be ended with this expression. Now, since we have 144, to get to 147, we need just to multiply both sides by 8. To the 3 is multiplied by 2 to the 144, which equals to 2 to 147, which is congruent to 8. Since 8 is 1 more 7, which is congruent to 1 mod 7, okay? Now I have ended with this expression. 2 to 147 is a congruent to 1 mod 7, okay? Now I'm going to bring this one down here. Now the next thing here, now I'm going to apply the Euler theorem on our problem. First of all, we are going to check the GCD of this one first. We have GCD of the base 2 and the n, which is 343 equals 1. In the other word, 2 not divide 343, okay? Since we have GCD of these two terms equals 1, that means we are allowed to apply the Euler theorem, okay? We have the base number 2 to the phi of 343 is a congruent to 1 mod 343, okay? So now I'm going to calculate phi of 343 by applying this formula, okay? So I have phi of 343 equals 343 factor. Now we are going to look for the factorization prime. Which the factorization prime for 343? As we said before, 343 equals 7 cubed. That means 7 as a prime is a divisor of 343. That means the factorization prime of this one, which is 7. This one will be written on this form: 1 minus 1 over 7. We have only one factorization prime here, okay? So now this one is giving us 7 minus 1, which is 6 over 7. It will have 343 is multiplied by 6 over 7. As we know, 343 divided by 7 is giving us 49. 49 is multiplied by 6 is giving us 294, okay? Now I'm going simply to replace this value of phi of 343 here to see what's given us. I will have 2 to the phi of 343, which equals 2 to the 294. As we know, 294 is the same as 2 to 147 to the 2, okay, like this. This one is a congruent to 1 mod 343 by applying the Euler Theorem, okay, this one. Now here is the problem. We'll have two cases. We'll have 247 is a congruent to 1 mod 343, or 247 is a congruent to minus 1 mod 343, because after you raising number to as an exponent on both sides, both statements taking you back to the same original one, okay? We cannot have both statements here, so we are going to eliminate one. Which one will be eliminated? Now we are going to force the second one to be eliminated, okay? So previously we have proven this fact, so we are going to select which one of this one is right, okay, by using this fact as an earlier proof. So by the way of contradiction, suppose this one 2 to 147 is a congruent to minus 1 mod 343, okay, so this one equivalent 247. By taking this minus 1 to the left, I will get plus 1 is a congruent to 0 mod 343, okay. This one is telling us 343 divides this term to 247 1, okay. So the trick that I'm going to use now, I'm going to reduce the divisor of this one. So as we have 343 equals 7 cubed, that means 343 is a multiple of 7. So in the other word, since this divisor, which is bigger, is divide this term, that means 7 divides 247 plus number 1. Since this one divides this one automatically divides this one, because this one is a multiple of this one. According to the divisibility statement, I'm going to express this one as this one equivalent 247 plus 1 is a congruent to 0 mod 7, okay. By taking this number 1 to the right, I will get 247 is a congruent to minus 1 mod 7. By using this previous fact, I have the same thing. I have 247 is a congruent to 1 mod 7. I have 247 is a congruent to minus 1 mod 7, which means 147 is a congruent to 1 is the same at the same time is a congruent to minus 1 mod 7, okay. So now by taking this minus 1 to the left, I will have 1 plus 1, which equals 2 is a congruent to 0 mod 7, okay. This one is telling us 7 divides 2, which is impossible, which is contradiction, okay. 7 never divide 2, which means this choice is ruled out of this possibility. So that's mean this one is a right choice, this one is a right one, okay. Thus 343 divides this term, which is 247 minus 1, okay. So I have proven this one. If you are interested to watch this one, don't forget to support us with your like and subscribe. Thank you for watching. I will see you next video. Bye.